Look up at the night sky. Take a deep breath. Let the cool air fill your lungs as you gaze at the shimmering dots of light scattered across the velvet darkness. It looks so peaceful, doesn't it? A silent, eternal painting hanging above our restless world. We often look to the stars to find calm, to escape the noise of our daily lives. But what if I told you that this absolute stillness is an illusion? Behind this serene facade lies an arena of unimaginable power, a place where giants roam. We are about to embark on a journey to witness the greatest predators in the history of the universe. Giants that do not hunt with teeth or claws, but with the silent, inescapable pull of gravity. Close your eyes for a moment. Imagine leaving your room, drifting up past the clouds, past the moon, out into the great cosmic ocean. Let go of your earthly worries. Today we will witness the majestic, terrifying, and ultimately beautiful phenomenon of the Cannibal galaxy. You are safe. You are just a silent observer in the grand theatre of the cosmos. To truly understand the scale of what we are about to see, we must first travel back in time. For centuries, humanity believed the universe was a static, unchanging place. The stars were fixed on crystal spheres, rotating in perfect, eternal harmony. It was a comforting thought, a predictable clockwork universe. But in the early 20th century, an astronomer named Edwin Hubble peered through a powerful telescope and shattered that glass ceiling forever. He discovered that those fuzzy clouds of light in the night sky were not just gas within our own neighborhood. They were entirely separate islands of stars, millions of light years away. Galaxies. And more astonishingly, he found that the universe was expanding. Everything was moving. The cosmos was not a still painting, it was a breathing, dynamic, and sometimes violent ecosystem. Galaxies are not solitary wanderers. They are social creatures, bound by the invisible threads of dark matter and gravity. They cluster together, they pull at one another, and sometimes they get too close. This is the stage upon which our cosmic drama unfolds. A universe in constant motion, where survival means consuming the weak, and where destruction is simply the first step in creation. But how does a galaxy become a predator? Let us begin by breaking a common myth. We often imagine space as a completely empty void, a silent vacuum where objects drift aimlessly. In reality, the space between galaxies is filled with invisible forces, a complex web of gravity and dark matter. Our predator, a massive spiral galaxy, sits like a giant spider at the center of this gravitational web. Picture it as a glowing whirlpool, hundreds of thousands of light years across, spinning silently in the dark. Its immense mass warps the very fabric of space-time around it. This warping is the trap. Any smaller galaxy that wanders too close to this invisible depression is already caught, even if it doesn't know it yet. The hunt has begun, not with a sudden pounce, but with a slow, agonizingly beautiful drift. The bait for our cosmic predator is usually a dwarf galaxy. These are small, faint collections of a few billion stars, mere crumbs compared to the hundreds of billions of stars in a giant spiral. Imagine a tiny, glowing firefly wandering too close to a massive bonfire. The dwarf galaxy is drawn in by the irresistible pull of the giant. But this is not a quick demise. The approach takes hundreds of millions, sometimes billions of years. It is a slow, hypnotic waltz through the void. As the dwarf galaxy falls inward, it begins to feel the immense tidal forces of the larger galaxy. The gravity pulling on the near side of the dwarf is stronger than the pull on the far side. This differential pull is the beginning of the end. Now let us witness the power of cosmic tides. You might think of tides only in relation to our oceans, pulled by the moon. But on a galactic scale, tides are powerful enough to rip apart entire worlds. As the dwarf galaxy spirals closer, the giant's gravity begins to stretch it. Picture a piece of soft taffy being slowly pulled apart by invisible hands. The spherical shape of the dwarf galaxy distorts. It elongates, transforming from a round ball of stars into a long, glowing cigar shape. The stars that once orbited peacefully around the center of the dwarf galaxy are suddenly pulled out of their orbits. They are dragged away, stripped from their home, forced to join the dance of the predator. This brings us to a beautiful misconception. We often hear the word collision when talking about galaxies, and we imagine a catastrophic crash. We picture stars smashing into one another in blinding explosions. But the reality is far more poetic. Space is incredibly vast. The distance between stars is so immense that even when two galaxies collide, the stars themselves almost never hit each other. Imagine two clouds of smoke passing through one another. The stars glide past each other like silent ghosts in the night. The true violence happens not to the stars, but to the structure of the galaxy itself. The dwarf galaxy is not shattered, it is unraveled, thread by thread. As the dwarf galaxy is unraveled, it leaves behind a magnificent trail. We call these stellar streams. Imagine a glowing river of stars wrapping around the giant galaxy like a luminous ribbon. These streams can stretch for hundreds of thousands of light years. They are the beautiful, lingering ghosts of the devoured galaxy. When astronomers look at a massive galaxy, they can often see these faint ribbons crisscrossing its outer halo. They are cosmic fossils, telling the story of past meals. Each stream is a silent monument to a dwarf galaxy that ventured too close to the predator and was slowly, meticulously dissolved into the greater whole. The hunt is not just about capturing stars. In fact, stars are just the shiny exterior. The true prize in this cosmic feast is gas and dust. Dwarf galaxies are often rich in cold hydrogen gas, the raw material needed to build new stars. When the predator pulls in the dwarf, it also strips away this precious gas. Imagine a vampire drawing not blood, but the very essence of life. As this fresh gas plunges into the giant galaxy, it creates shock waves. These shock waves compress the gas clouds within the predator, squeezing them until gravity takes over, sparking a magnificent reaction. From the destruction of the dwarf galaxy comes a breathtaking burst of creation. The compressed gas clouds ignite. Millions of new stars are born in a relatively short period, an event we call a starburst. Imagine fireworks blooming silently across the spiral arms of the giant galaxy. Brilliant, hot, blue stars burst into existence, lighting up the dark dust lanes. This is the great paradox of the Cannibal galaxy. It is a destroyer, yes. It tears apart smaller neighbors without mercy, but in doing so, it breathes new life into itself. Without this constant feeding, a giant galaxy would eventually run out of gas. Its star formation would cease, and it would slowly fade into a red, dead collection of aging stars. But what lies at the very heart of the predator? Deep within the core of almost every giant galaxy, including our own, lurks a supermassive black hole. This is the ultimate abyss, a point of infinite density where gravity is so strong that not even light can escape. When a galaxy feeds, it is not just the spiral arms that get new material. Some of the gas and dust from the devoured dwarf galaxy is funneled all the way down into the center, directly into the waiting maw of the black hole. Imagine a colossal cosmic drain pulling in everything that comes near. As this material falls toward the black hole, it doesn't just drop straight in. It swirls around, forming an accretion disk. Imagine a whirlpool of glowing plasma spinning at nearly the speed of light. The friction in this disk is unimaginable. The gas heats up to millions of degrees, glowing with a fierce, blinding light in X-rays and ultraviolet radiation. The black hole is feeding. During this phase, the center of the galaxy can become brighter than all the billions of stars in the galaxy combined. This brilliant active core is called an active galactic nucleus, or a quasar. It is the glowing eye of the predator, visible from billions of light years away. But the predator cannot eat forever. The supermassive black hole is a messy eater. As it consumes matter, magnetic fields twist and snap, channeling enormous amounts of energy outward. Huge jets of plasma are blasted away from the black hole at near light speed, piercing through the galaxy. These jets act like a cosmic burp, blowing away the remaining gas and dust in the galaxy's core. Imagine a hurricane-force wind clearing away the fog. This process actually halts the feeding. It pushes the star-making material out of the galaxy, temporarily starving the black hole and stopping the birth of new stars. It is a perfect, violent mechanism of self-regulation. Now let us bring our gaze closer to home. You might be listening to this, feeling safely detached from these violent cosmic events. But here is the beautiful truth. We are living inside a predator right now. Our own home, the Milky Way galaxy, is a massive spiral. It is a giant, majestic wheel of hundreds of billions of stars, and it has not grown to this size by being peaceful. The Milky Way is a cannibal. It has spent billions of years hunting, capturing, and devouring its smaller neighbors. When you look at the silver band of the Milky Way across the night sky, you are looking at the body of an ancient, successful hunter. In fact, the Milky Way is enjoying a meal right at this very moment. Let me introduce you to the Sagittarius dwarf spheroidal galaxy. It sounds complex, but imagine it simply as a small, unfortunate companion. It is currently in the process of being ripped apart by our galaxy's gravity. As we speak, the Sagittarius dwarf is looping around the Milky Way, leaving long, beautiful stellar streams in its wake. Our gravitational tides are tearing its stars away, pulling them into our own halo. Millions of years from now, the Sagittarius dwarf will cease to exist as a distinct object. Its stars will simply become part of our own sky. And Sagittarius is not alone. If you travel to the southern hemisphere and look up at a clear night sky, you can see two fuzzy patches of light. These are the Magellanic Clouds, the large and small Magellanic Clouds. They are dwarf galaxies, satellites caught in the gravitational embrace of the Milky Way. They are beautiful to look at, but their fate is sealed. They are slowly spiraling inward. Over the next few billion years, the Milky Way will tear them apart and consume them. They are the next course in the grand cosmic banquet. How do we know all of this? We cannot stand outside the Milky Way to see it happening. The secret lies in a remarkable spacecraft called the Gaia Space Telescope. Gaia is slowly, meticulously mapping the exact positions and movements of over 1 billion stars in our galaxy. By looking at how these stars move, astronomers can spot the outsiders. Imagine looking at a busy city street and noticing a group of people all walking in the exact same direction, at the exact same speed. You would realize they belong together. Gaia has found groups of stars in our galaxy moving in peculiar synchronized ways. These are the remains of ancient meals. Through Gaia, we have uncovered a vast, hidden graveyard within the Milky Way. We have discovered the remains of galaxies with names like Kraken, Sequoia, and the magnificent Gaia Enceladus. Billions of years ago, Gaia Enceladus was a massive dwarf galaxy that crashed head-on into the young Milky Way. It was a monumental event. The impact swelled our galaxy's disk and scattered stars far out into the halo. The stars of Gaia Enceladus are still here, orbiting among us. You might even be looking at one of them when you gaze up at the night sky. The history of our galaxy is written in the blood of its victims. This realization changes how we see our place in the universe. We often think of Earth as an isolated island, but we are passengers on a massive ship that is sailing through a dangerous sea, constantly absorbing smaller vessels. The calcium in your bones, the iron in your blood, some of these elements were forged in the hearts of stars that belong to entirely different galaxies, brought here by the violent forces of cosmic cannibalism. We are not just in the universe, we are made of it. We are the recycled remnants of ancient, devoured worlds. But the story of the predator does not end here. The Milky Way may be a giant, but there is always a bigger fish. Look toward the constellation of Andromeda. There, lying 2.5 million light-years away, is a faint smudge of light. This is the Andromeda galaxy. It is our nearest large neighbor, and it is a monster. Andromeda is significantly larger and more massive than the Milky Way. It has 1 trillion stars, and just like us, it has a dark, violent past. It is an apex predator that has consumed countless dwarf galaxies in its time. Here is a myth we must shatter. The idea that space is expanding so fast that everything is moving away from us. While the universe as a whole is expanding, local gravity is stronger than the expansion. The Milky Way and Andromeda are locked in a gravitational embrace. They are pulling on each other with unimaginable force. Right now, as you lie there listening, Andromeda is rushing toward us at a speed of over 250,000 miles per hour. It is a slow, inevitable march toward the greatest collision in the history of our cosmic neighborhood. Do not panic. This grand event will not happen tomorrow. The Great Collision is scheduled for about 4 to 5 billion years from now. But let us use our imagination to travel forward in time. Imagine standing on a future Earth, looking up at the night sky. Slowly, over millions of years, that faint smudge of Andromeda will grow larger and brighter. It will stretch across the sky, a magnificent, terrifying sword of light hanging over the world. The glowing core of Andromeda will become as bright as the full moon, casting shadows on the ground. It will be the most beautiful sight imaginable. When the two titans finally meet, it will not be a sudden crash. It will be a slow, majestic, billion-year dance. The galaxies will pass right through each other. Remember, the space between stars is vast, but the gravity of each galaxy will deeply disturb the other. As they pass, they will pull long tails of gas and stars from each other, like cosmic taffy. The perfect spiral shapes of both the Milky Way and Andromeda will be completely destroyed. The night sky will be filled with a chaotic, brilliant web of scattered stars and massive glowing clouds of gas. After their first pass, the two galaxies will slow down, pulled back together by their mutual gravity. They will fall toward each other again, this time merging completely. The two supermassive black holes at their centers will spiral inward, eventually combining in a titanic explosion of gravitational waves that will ripple across the fabric of the universe. The gas clouds of both galaxies will violently collide, triggering a massive starburst. The sky will be ablaze with the blue light of millions of newborn stars. The two predators will become one. What will emerge from this monumental merger? The resulting galaxy will no longer be a flat, spinning spiral. The chaotic collision will scramble the orbits of the stars, throwing them into random paths. The new galaxy will settle into a massive, featureless ball of stars, an elliptical galaxy. Astronomers have already given this future giant a name, Milkomeda. It will be the retirement home for our stars. The gas will be used up, star formation will eventually cease, and Milkomeda will glow with the calm, steady light of ancient, aging stars. You might be wondering about the fate of our own sun and our little blue planet. Will Earth be destroyed in this cosmic war? Surprisingly, the answer is likely no. The distances are so great that our solar system will almost certainly not collide with another star. However, we will be evicted. As the gravitational forces wildly fling stars around, our sun will likely be tossed far out into the outer suburbs of the new Milkomeda galaxy. We will have a new, vastly different view of the night sky, looking back at the glowing heart of the merged giant from the cold, quiet edge of the new galaxy. This dance of giants is not unique to us. If we zoom out, far beyond our local group of galaxies, we see this process happening everywhere. The universe is a vast, cosmic web composed of glowing filaments of dark matter and gas. Galaxies flow along these invisible rivers, gathering where the filaments intersect. These intersections form massive clusters, containing thousands of galaxies. In these densely packed environments, galactic cannibalism is a daily occurrence. The predators are everywhere, constantly merging, constantly growing. At the center of these massive clusters often sits a true monster, a supergiant elliptical galaxy. These are the undisputed kings of the universe. They have grown so large, hundreds of times the mass of the Milky Way, by devouring everything in their path. They sit at the bottom of a deep gravitational well, pulling in any galaxy unlucky enough to wander too close. Imagine a bottomless pit of stars, a monument to billions of years of relentless consumption. They are terrifying in their scale, yet profoundly peaceful in their slow, ancient existence. Even the Milky Way and Andromeda are part of a larger flow. We are all moving toward a mysterious, incredibly massive region of space known as the Great Attractor. It is a gravitational anomaly so powerful that it is pulling hundreds of thousands of galaxies toward it, across hundreds of millions of light years. We cannot see it clearly because it lies hidden behind the thick dust of our own Milky Way's disk. But we can feel its pull. It is a reminder that in space, gravity is the ultimate architect, the invisible hand that shapes the destiny of everything we see. Let the scale of this wash over you. Think of the petty concerns of our daily lives, the noise, the stress. Then, imagine the slow, silent ballet of galaxies spinning through the dark. A billion years is just a moment in cosmic time. A trillion stars are just a handful of dust in the wind. There is a deep comfort in this realization. We are part of something so much grander, so much more profound than we can ever fully comprehend. The destruction we see in the heavens is not evil, it is the fundamental process of creation. Without the cannibal galaxies, without this constant cycle of merging and devouring, the universe would be a dark, cold, and boring place. It is through these violent collisions that gas is stirred, new stars are ignited, and heavy elements are scattered across the cosmos. The iron in your blood, the carbon in your DNA, was forged in stars that lived and died long ago, scattered by the winds of galactic mergers. We owe our very existence to the predatory nature of the universe. We are the children of the cosmic storm. As you continue to relax, visualize that stellar stream again. A glowing ribbon of silver light stretching across the infinite black canvas. It is a river of memory. It tells a story of a long journey, of a slow surrender to a greater power. Imagine floating along that stream, weightless, silent, carried by the gentle, irresistible pull of gravity. There is no need to fight it. There is only the peaceful surrender to the flow of the cosmos. Everything is exactly as it should be. The universe is unfolding in its perfect, eternal rhythm. The Cannibal galaxy is not a monster to be feared. It is a master sculptor, carving beauty out of the void. It is a reminder that even in the darkest, coldest depths of space, there is movement, there is energy, there is life. As the galaxies dance and merge, they create the stunning tapestry of the night sky that we so love to admire. They are the great engines of eternity, turning the wheels of time, ensuring that the light of the stars will never truly fade away, but only transform into something new, something breathtakingly beautiful. And so, our journey through the dark and majestic hunting grounds of the cosmos comes to a gentle close. We have witnessed the silent power of gravity, the unraveling of dwarf galaxies, and the spectacular rebirth of stars in the heart of the predator. We have seen that the very violence of the universe is the cradle of creation, and that we, here on our small blue world, are intimately connected to this grand billion-year dance. Slowly, let your mind return from the distant edges of Andromeda. Drift back past the stellar streams, past the swirling core of the Milky Way, and feel the solid comfort of the Earth beneath you once again. You are home, safe beneath a sky that is alive with history and future promise. Thank you for traveling with us through the endless wonders of space. If this journey brought you peace and a new perspective, please leave a like and subscribe for more adventures into the unknown. And before you drift off to sleep or continue your day, I leave you with this question to ponder in the comments. When Milkomeda finally forms billions of years from now, do you think there will be someone out there looking up at that new, chaotic sky, wondering where they came from?